Welcome to the deep dive. Okay, so the software world, it's just evolving incredibly fast, isn't it?
It really is. You've got these huge breakthroughs in AI, all the shifts happening in Web3, edge computing popping up.
Right, and that whole automation first mindset everywhere, it feels like, something new every single day.
Totally. And you hear this question constantly in dev circles, right? What's actually the best programming language to learn, say, for 2026?
Exactly. So that's our mission for this deep dive. We want to give you a kind of shortcut to getting really informed on this.
Makes sense. Cut through the noise a bit.
Yeah.
Yeah.
We've dug into this great DDV community article, Best Programming Language for 2026, and crucially, the comment section, too. Some fascinating stuff in there.
Oh, the comments are often where the real gold is, the different perspectives.
For sure. So our plan is to break down the top languages,
Yeah.
figure out where demand's really growing,
Which ones might lead to those high-paying jobs everyone's after?
and importantly, what use cases are actually going to matter in the next, say, 3 to 5 years. Okay, let's try and unpack all this.
Yeah.
We want to help you navigate this, whether you're maybe just starting out or thinking about your next big career move. It's really about finding the language that fits your goals, what sparks your curiosity.
And I think it's important, like the article points out, not to just see this as like a popularity contest.
Right.
It's more strategic. It's about where tech is heading and fundamentally what kind of problems you want to solve.
That strategic angle definitely shifts the conversation.
Okay, so thinking strategically then, where do we start? Python keeps coming up, doesn't it? The timeless titan.
Oh, absolutely. It's still dominant in AI, machine learning, data science. You just can't ignore it there.
And it's used heavily in automation too, right? Backend stuff, scripting.
Yep, all of that. Plus, the community is just enormous. And the ecosystem. You've got tools like PyTorch, TensorFlow for ML.
Right, the big hitters in machine learning development and deployment. And Fast API is getting huge for building web APIs quickly, high performance stuff.
So if we look at the job market then, how does Python stack up?
Still easily in the top 3 most in-demand languages globally. It's just everywhere. Startups use it. Big tech like Google and Meta rely on it heavily. Fintech, edtech, you name the sector, Python's probably there. So it's a great path for AI researchers, DevOps engineers, indie hackers doing automation, data scientists.
Yeah, that makes sense. The article had a neat little example too, didn't it? A Python script using the OpenAI API.
Yeah, GPT-4o, I think.
Right, to explain quantum computing simply. It just shows how practical it is.
And I think the real insight there isn't just that it powers AI, but how its simplicity and its amazing libraries have sort of democratized it.
Democratized AI, how so?
Well, it makes complex data science and advanced computing accessible to way more developers than ever before. You don't need a PhD in comp sci to start doing really cool things.
That is pretty incredible, actually, making it accessible. Okay, so Python's great for that high-level stuff, democratizing AI, but sometimes you need raw speed, right? Getting closer to the metal.
Exactly. And that's where Rust comes in. It's really making waves as the performance powerhouse.
Yeah, I keep hearing more and more about Rust. System-level stuff.
System-level apps, yeah. Blockchain tech relies on it heavily now. WebAssembly, running code fast in browsers, embedded systems, like in smart devices.
And big companies are adopting it.
Oh, yeah. Amazon, Google, Microsoft, Dropbox, they're all using Rust for critical systems. And get this, Stack Overflow's most loved language for 6 years running.
6 years, wow, okay.
Right.
That's quite the endorsement from developers themselves.
Yeah.
So what's the core advantage? What's the big deal?
Well, the really profound thing about Rust is how it tackles that classic problem. How do you get super high performance without sacrificing memory safety?
The age-old trade-off.
Exactly. Rust gives you memory safety without needing a garbage collector, which is a huge performance win. So it's ultra fast, but also secure. It's kind of the holy grail for certain types of development.
Okay, so memory safety, no garbage collector, super fast. Who's this best for then?
Definitely systems programmers, people building operating systems, low-level stuff, blockchain developers, absolutely, and anyone building game engines or VR engines where performance is just critical.
Right. Here's where it gets really interesting if you're looking for that kind of efficiency and control, especially in demanding areas.
Yeah.
Okay, so from low-level systems, let's jump back up to the web. JavaScript and TypeScript still rule there, right?
They absolutely do. But the interesting thing is the evolution. TypeScript is pretty much the default now for any serious front-end or even back-end team.
Why the shift to TypeScript?
That type safety it adds on top of JavaScript, it just catches so many errors before they hit the user. It's a massive productivity booster for teams.
Makes sense. Fewer runtime bugs.
Exactly. And you see these modern JS frameworks everywhere. Svelte, Next.js, Solid.js, they're kind of dominating. JavaScript, or really TypeScript now, is the glue holding together full-stack AI apps, browser agents, those progressive web apps.
CWAs, yeah. The ones that feel like native apps.
Right. So obviously it's key for web developers.
But not just web devs.
No, it's also great for indie developers building tools, SaaS apps, dashboards, and full-stack teams using Node on the back end, maybe Vite or Astro for the front-end tooling.
Yeah.
It's a really versatile ecosystem.
The source even mentioned using TypeScript to fetch output from large language models via APIs, right?
Yeah.
Shows how central it is to modern web workflows.
Definitely. It connects everything.
Okay, so web is covered.
Okay.
What about the back end? We mentioned Node with JavaScript, TypeScript, but there's another big player, Go, or Golang, still a beast there.
Oh, yeah. Go is still incredibly relevant for back-end systems. Its big selling point is how it handles concurrency, doing lots of things at once.
With the Go routines.
Exactly. They make parallel programming much, much simpler compared to other languages. Plus, it's got a clean syntax, really good built-in tools.
And it powers some pretty critical infrastructure, doesn't it?
It really does. Think Docker, Kubernetes for container orchestration, Tailscale for secure networking, Cloudflare's infrastructure. Go is running behind the scenes in a lot of important places.
So key use cases would be microservices.
Definitely microservices. Building those small, independent backend services, also great for command line tools, infrastructure as code, and just building high-performance APIs.
So if your goal is building really robust, scalable backend stuff, Go is a strong contender.
Absolutely. Ideal for cloud engineers, back-end devs focusing on microservices, API builders.
Got it. Okay, shifting gears slightly. What about the mobile world? If you want to build mobile apps in 2026.
Well, that's pretty clear-cut, actually. You've got Swift for the Apple ecosystem, iOS, macOS.
And now the Vision Pro stuff too, right? Spatial computing.
Exactly. Swift is extending into that, offering great performance and obviously deep integration with all things Apple.
And for Android.
It's Kotlin. Kotlin has basically fully replaced Java for new Android development, and Kotlin multiplatform is also gaining a lot of ground.
Multi-platform. So write once, run on both iOS and Android.
That's the promise, yeah. It's getting more popular for teams wanting to share code bases. So, bottom line, if you're serious about mobile dev in 2026, Swift and Kotlin are kind of non-negotiable.
Okay, makes sense. Now, the article mentioned a runner-up. Julia, that sounds a bit more niche.
It is more niche, but really powerful in its domain. It's gaining traction in high-performance scientific computing, HPC.
So not general purpose, but for specific heavy-duty tasks.
Right. In climate modeling, complex financial simulations, computational biology, places where you need serious number crunching speed.
The article had a good analogy for it.
Yeah, it said, if Python is the everyman's AI tool, Julia is the scientist's. Which I think sums it up nicely. It's specialized but incredibly powerful for scientific and numerical work.
Interesting. Okay, beyond those main players, the sources also touched on a few other languages, right? More niche, maybe, but solving specific problems.
Yeah, definitely worth a quick mention. For example, there's Zig.
Zig, what's that for?
It's popping up as a modern alternative to C for really low-level systems programming, OS development, offers more safety, newer features.
Okay. And you mentioned Elixir earlier.
Right. Elixir is great for real-time stuff, scalable APIs. You see it a lot in fintech, chat applications. Anyway, you need to handle tons of concurrent connections reliably. It's built on the Erlang VM, known for fault tolerance.
Fault tolerance, nice.
Yeah.
Any others?
Nim came up. It's kind of interesting. It has Python-like syntax, easy to write, but it compiles down for high performance.
So best of both worlds, potentially.
Sort of, yeah. Good for game dev, scripting, embedded systems where you want that mix of usability and speed.
And one more, Haskell. That sounds more academic.
It has roots in academia, yeah. Very strong focus on functional programming, type theory, mathematics. It's used in writing compilers, some areas of fintech, and places where correctness is absolutely paramount for people who really appreciate the theoretical side of programming.
Gotcha. So lots of options beyond the big names, depending on what you want to do.
Exactly. Now, the article laid out a strong case for Python, Rust, JSTS, Go, and the mobile kings. But you mentioned the comments section earlier. That really raises an important point, doesn't it? The article presents one view, but what about languages that are still massively relevant but maybe didn't top that specific list? Context matters.
It absolutely does, and the comments really hammered that home. One of the biggest things was Java. Lots of people saying, hey, where's Java?
Still a back-end giant, right, especially in big companies.
Totally. Many argued it's probably still the #1 back-end language in large enterprises.
Yeah.
Though there was nuance, too. Some said it might be overkill for tiny applications.
Fair point. Enterprise strength versus lightweight needs.
And interestingly, a contrasting view popped up regarding Go. Someone argued Go might not be mature enough for enterprise backend compared to Java.
Highlighting Java's decades of being battle-tested in those environments. That makes sense. Reliability is huge there.
It wasn't just Java getting love in the comments either. What about C#?
Right. C# got highlighted too, people saying it's really good for backend, especially within the whole .NET ecosystem. If you're in a Microsoft shop, it's incredibly strong.
Agreed. And then there's the old guard, C and C++.
Yeah?
Still relevant.
According to the comments, absolutely. Especially in specific domains, C++ and C# were mentioned as basically unparalleled for high-performance game engines.
Makes sense. Speed is everything there.
And C and C++ are still the kings of embedded systems where you need that direct hardware control. They aren't going away anytime soon in those areas.
So it really drives home that point. The best language. It just depends so much on the use case, the industry, maybe even the company's existing tech stack.
Exactly. Looking at those community comments really broadens the picture and stops you from getting too narrow a view. The landscape is diverse.
Okay, so weaving all this together, what does it mean for you, the listener, trying to figure out your next step? How do you choose?
Well, the source actually provides some really good guiding questions for self-reflection.
Okay, let's hear them.
First, do you want to build primarily for humans or for machines?
Interesting distinction. So like web UI for humans.
Right. If it's web UI, lean towards TypeScript. If it's back-end systems talking to each other, maybe Go or Rust. If you're building for devices, OS-level stuff, then Rust or maybe Zig.
Okay, question 1. Humans or machines? What's next?
Second, are you heading in a direction that's heavy on AI?
If yes.
Then the combo of Python plus Rust is recommended. Python for the high-level AML work, Rust for performance-critical parts, maybe even C++ if you're diving really deep into AI framework development.
Got it. Python plus Rust for AI. Third question.
Are you interested in the startup world? Building SaaS products, automation tools, maybe being an indie hacker?
Yeah.
Then the focus should probably be on Python plus JavaScript, TypeScript. That combo lets you build minimum viable products, MVPs, really fast, and automate things easily using APIs.
Speed and flexibility. Makes sense for startups.
Yeah.
Okay, final question.
Finally, do you want to freelance easily or land remote jobs relatively quickly?
What's the advice there?
The recommendation is to learn TypeScript, Python, and maybe some Go. Those seem to be highly in demand for remote and freelance gigs right now.
That's super practical advice.
Yeah.
And the article had a nice summary too, didn't it? The sort of TLDR by career path.
Yeah, it broke it down really clearly.
Okay, run us through it.
AML, Python, Rust, Fullstack Web, TypeScript, Python, Systems and Blockchain, Rust, Go, Zig, mobile apps, Kotlin, Swift,
And the last 2.
freelance and automation, Python, JavaScript, TypeScript, and scientific research. Julia, Python.
Okay, those pathways provide really clear guidance. Helps you narrow things down based on where you actually want to go.
Definitely. It connects the languages directly to aspirations.
So as we kind of wrap this up, the big takeaway seems to be the best language in 2026. It's not just about what's popular or trending on GitHub.
No, not at all. What's really compelling here, I think, is that it boils down to what you want to build and how quickly you can take your ideas and turn them into something real, something working.
Right.
And, you know, with everything happening, multimodal AI agents becoming a thing, cloud-native development being standard, decentralized infrastructure, growing the languages we've talked about, they aren't just surviving, they're actually thriving and actively shaping what's next.
That's a great point. They're enabling the future.
Mm-hmm.
So the final thought, maybe, pick the language that genuinely sparks your curiosity, right?
Exactly. The one that aligns with your goals.
Mm-hmm.
The one that helps you get your ideas out there. Because, as the source powerfully puts it,
Go on.
the best code is the one you actually write.
Love that. Just start building. Choose your tool and build.
Precisely. And hey, if anyone listening is inspired to jump in, the original article listed some really good resources to get started. Things like the Rust book, Real Python for Python beginners, the official TypeScript docs, Go by Example, guides for learning Julia, and roadmap.esh, which is great for visualizing tech career paths.
Excellent. Plenty to explore further then. Thanks for breaking all that down.
My pleasure. It's a fascinating landscape right now.